All right, guys, we are now recording. And
all right, hi everyone. We're giving a talk about this snazzy IDS that my friend here and I have written over the summer. It's called antipwny. So we're gonna start with a little bit of background about us too. We're both students at Towson University. We're enrolled in the computer science security track, where we do all sorts of fun stuff related to, believe it or not, security. We're both currently unemployed, so if any of you guys want to offer us jobs, we're 100% okay with that. We even brought resumes just to make it easy for you guys. We're not desperate. We're not desperate, but seriously. So before we really get into our actual IDS, we're actually going to do a really quick presentation about Meterpreter. Just quick show of hands. How many people here know what Meterpreter is? Okay, good majority of you. But we're going to do this anyway, just so we can catch everybody up to speed. So, go for it.
Alright, we're just going to target Windows 7 Service Pack 1. I'm just going to use a Java exploit, so pretty simple stuff. Use Java Rhino, because it always works.
Java Rhino is probably the most dependable Java exploit I've ever seen. It gets you to shell pretty much most of the time. Is it Service Pack 1? Is it Service Pack 1? Yeah. We did disable UAC because we wanted to make this demo a little easier.
And faster.
And faster, yes. This is doable with UAC, obviously, but it complicates things. And this isn't really the purpose of our demo, so. So for those who don't know, David here is going to totally not malicious. And he is telling Java to run even though he shouldn't. But Meterpreter is a payload designed by the good folks at Rapid7 for their pen testing framework, Metasploit. It's a really snazzy payload that can let you do lots and lots of really, really mean things. As you see, we have pwned the computer. The computer now has Meterpreter on it. Lightning bolts are the coolest thing ever. Whoever designed this interface is awesome. Actually, I know who it was. So, just to give you a quick rundown, we can do a lot of different things with Meterpreter once we've compromised your system. This is like a little list of them in nice GUI format, because who doesn't like GUIs? We can do all sorts of stuff like dump all the password hashes, at which point, we can just take whatever password hashes you have, we can crack them, we have your passwords now. That's all fun. You can do other fun stuff, like you can
ignore that.
Sometimes you leave stuff on test systems that you don't need to. You can do other fun stuff. You can take screenshots of their computer. You can turn on their webcam, take a picture of them, and see what they're doing. Just if you want to be really trolly. You can do a heck of a lot of stuff. Meterpreter makes it really easy. This is the premier payload for Metasploit. A lot of people write their own custom ones, but if you use the basic stuff, so there's a screenshot right there. This is what's on the other desktop that's been compromised right now. Totally not malicious. If most generic exploits in Metasploit are going to use Meterpreter as their payload. It's a powerful remote administration toolkit. It resides completely in memory. It never touches the disk, which makes it a lot harder to detect for a lot of different things. But it's really nifty, it's really easy to use, so why not use it? So we decided we want to find it. Because, well, we've been through our fair share of CTFs and competitions. And yeah, Meterpreter hurts. So this is our project that we've been working on. We actually started this as a research project to try and signature Java exploits. You saw Rhino up there a second ago. Eventually, we kind of accidentally found a way to detect Meterpreter. It wasn't our original intention. I got really bored one day and spent like 30 hours looking at Meterpreter code, and I found it. Yeah, 30 hours in one day. And our professor was like, our professor back there, by the way, Dr. Louie, he basically said to us, why are you bothering to signature Java exploits if you can signature the payloads we're using? And I thought, you know, it's actually a really great idea. So we made an IDS out of it. But we decided to expand it a little further than that. We wanted to target all the payloads that you can have in Metasploit. There's a lot of different things you can do with Metasploit framework. You can do reverse shell. There's a Java Meterpreter. There's the regular Meterpreter. We wanted to find them all. So we decided to write this all in C#, make it completely on Windows, because C# makes it really easy to make a GUI. And honestly, I am terrible with coding for Linux. So we get a little bit into the inner workings of antipwny here. We want to cross-reference as many data points as possible. Because this is an IDS primarily, we want to let the user make a decision on what they're doing. And we give them as much information as we possibly can, and then let them decide what they want to do with it. We actually wrote a memory scanner from scratch to find signatures in memory. As I mentioned a little briefly, Meterpreter does not ever touch the disk in its regular format. So we actually pull in the memory of every single process on the system in our own program, and we scan it. And we look for a very, very specific signature, which is always the same no matter what you do with Meterpreter. We also do fun things like we read the whole TCP table and we try and find anything that looks suspicious. We cross-reference that with the Meterpreter we found. If there is something that looks like Meterpreter connecting out on a very, very high port to a random IP address, that's usually a good sign something is wrong. So the real interesting part of Meterpreter that makes it really hard to play with is it can exist anywhere. It can exist in Notepad, which is the most common one. It can exist in WinLogon, which is not good. It can exist in theoretically any process on the system except for maybe the system process, which isn't really a process. So it doesn't count. After loading it itself, it actually loads this whole function call table into memory. So every time you do a command on your end and you say, do this, Meterpreter on the other end says, hey, here's my function. And that's actually what we're looking for. Each entry in the table is a specific function. We actually look for standard API underscore sys underscore process under gets PID. Get PID gets you your process ID. Very simple function. This is how I accidentally stumbled upon this. Searching through memory and you search for the string get PID. Congratulations, you have a signature from Meterpreter. Now, as I said before, we do take the outbound connections from this process to give the user as much information as possible. If you've ever participated in any of the CCDC competitions, one of the things you have to do is file incident reports, in which you have to basically tell the white team what exactly happened, who did it, and what your proof is. So we kind of want to give you as much proof as possible. Another thing you do is reverse shells. Now, this is actually really funny because you would think a reverse shell is just command.exe running. It turns out, in the case of Meterpreter, it is actually a Meterpreter shell spawning a command.exe underneath it. So if we find Meterpreter, we find reverse shells as well. So we pretty much just look for a very, very, very crazy named executable, usually like capital Y underscore UIJK.exe. And we say, oh, is there command.exe running under it? That's probably not good. So if we find it connecting outbound, we found something. Now, here's where it gets very interesting. Persistence is a nasty, nasty thing that you can do with Meterpreter, which allows you to persist. Every time the user reboots their computer, you get a shell back. Every time the user logs off and logs on, you get a shell back. It's really, really annoying, and it's actually really hard to get rid of. It actually uses a lot of different things together. The first thing it does is drop a VBS file in your temp folder. Who here has used a VBS file in the last, I don't know, like 4 years? Okay, so like 2 people. So if you find a VBS file in your temp folder, you should be worried because that shouldn't be there. It also creates a bunch of registry entries. We find those too because, like I said, they're very obvious and we want to find everything we can. If you find a registry entry that looks like a very random name, like capital Y underscore U WXYZ, that's not good either. Then it runs a nice little executable on your computer, either WScript or CScript. And we've actually found both of them. And
kind of randomly also.
Yes, very
Doesn't
random.
seem to matter what you do.
If those are running, they're usually calling the VBS file in the temp folder, and they spawn a Meterpreter executable every 4 seconds. And they try to connect back. And that is the actual persistence method. So You have to find that too. We actually read command line parameters for it, and we see what it's calling. If it says .vbs in it and it says temp in it, you can kind of figure it out from there. So there's more registry keys here. These are actually the real values. They go in HTTP local machine, HTTP current user, and services, and they're just spawn all the time. It's actually really, really nasty to watch. So, question is, what do you do after detection? We actually do have an IPS mode, but I'll talk about it a little bit more. In IDS mode, we want to present everything we can to the user and let them make a decision on it. We'll log everything to a file, so you can look at it later, and you can see what you did, what we detected, why we detected it, and they can do whatever they want. We give them the option to kill the files, we give them the option to kill registry keys, you can do anything. In IPS mode, our current functionality is literally just nuke it from orbit. If we find Meterpreter in anything, we kill it, which is not necessarily a good thing, because if Meterpreter's in, I don't know, WinLogon, we kill that too. And we've crashed plenty of VMs by doing this in our testing. That's something we'll talk about a little bit more. So IDS mode actually works really, really well in antipwny. I think we've picked up just about every payload you can drop through native metasploit. We're moving on to other stuff, but it's still there. IPS mode works. It's very slow. This is one thing we've been trying to figure out. We don't know why it's slow. It seems to make sense the way we're setting it up, and yet sometimes it just doesn't work.
It'll kill the shell that you have in anywhere between 5 seconds and about 2 minutes, kind of randomly.
2 minutes is a long time for a shell detector system. And like I said, it's very dangerous. Any infected process will be killed. We do run antipwny as a super user, so we do have permission to kill any process on the system, which leads to serious problems when they're in any process that's kind of essential. So we have some planned features, but we'll talk about this a little bit more after we actually give our demo.
All right, so we're going to use our handy-dandy shell that we already got here, and then run antipwny against it, like our little logo.
If you like our logo, that is actually a pony from My Little Pony with a giant cross over it. Because, I mean, hey, it makes sense. So this is our IDS, and that is a detected shell. It took, I don't know, maybe 10 seconds to scan the whole system. We actively scan the system every minute. We schedule scans for you. We keep looking. We also have an active scan component where every time something happens, like a new process is created, or a new registry key is added, or a new file is created, we scan that too. We wanted to find stuff as fast as we could, but it's not always 100% accurate. So you can see we actually give you a PID. We give you what it is. We give you the process. We give you where it is. We give you the outbound connection as well. So we're enumerating all the data we can to give you the opportunity to right-click on it and hit kill process. At which point, congratulations, you picked an attacker off the box. That's very good. If you've ever been in any of the CTF competitions or any of the CCDC competitions, that happens all the time. And what they do is not nice and happy and sunshine. They'll do mean things like erase big folders on your computer. So you want to get rid of them as fast as you can. So David is actually going to run a persistence script, so I can show you that as well. So there you go. We've already found the persistence C script right there. That is the crazy, crazy persistence that will continue to run no matter what you do until you kill it. And actually, in our initial testing, we spent a long time trying to figure out how to kill persistence, and we never found that executable. And it was a serious issue because we pretty much never killed it for probably a couple of weeks. Yeah, kind of sad. And there you go. We spawned another Meterpreter shell. So there's actually 2 shells in the system now because persistence made another one. As long as we kill those, as long as that C script is running, it'll keep making more and more and more and more and more. It's incredibly annoying. Apparently our registry tab is broken because the demo gods hate us. Try that. There are many types of persistence, by the way. There are user logon, machine startup, services. A lot of their own thing. our registry tab magically broke because, as I said, nothing ever works in a demo. All right, it works, I promise. You can look at the code on our GitHub. It works. So we also actually have an event log that goes with it. This is actually a running log of everything that happened. It also writes to the file, output.txt, because it's cool name. We also have a configuration tab, which is completely and utterly useless in every way, shape, or form. It literally does nothing right now. There's a box. You can type in the box. It won't do anything, I promise. We haven't hooked any of it up because this is a work in progress still. Yes, that is not the new log file process. So we actually do allow you to run antipwny at startup, because if there's one thing you want on your computer every time it comes on, it should be your IPS. And we do have an IPS mode, and I explained why that was a terrible idea earlier, but David's going to do it anyway. Why not? So the fun thing about IPS mode is every single time we do an active scan of your system, every minute, anything we find, we immediately kill it. We don't really care what process it's in. We don't care about any of that fun stuff. We just kind of nuke it.
As I said, it can take any random amount of time.
There you go. All gone.
That took like 30 seconds.
Attacker just lost all three of his shells in 30 seconds. And we conveniently log to you everything that happened. And as you can see, C-script is continuing to drop lots and lots and lots of Meterpreter files into your temp folder. And it will keep doing that forever. All right, so the fun thing is this whole project right now is up on GitHub. We do have a lot more planned features for this, so we're not actually stopping working on it. This is just as much as we can get done before this conference. We actually do want to add firewall support to this. The fun thing is, right now, you can kill an attacker and he'll get right back in. But if I have all the proof that I need to say this is an attacker and they dropped Meterpreter on my system, why not firewall them off? Why not just keep them out? In any of the major competitions, that's all the proof you need. If you have conclusive proof that they have Meterpreter on your system, you've proven a compromise, you can firewall them. So we want to integrate that directly into our program. If we can firewall them from there, make it that much simpler for the user to use. Smarter payload killing is very important, as I've mentioned like 3 times now. Yeah, we don't want Meterpreter and WinLogon being killed by antipwny. We wanted to kill the connection instead. That's actually a safer way to do it, because you still get rid of the attack, but you don't kill your whole system, which is pretty important.
Have you considered terminating the specific threads, or maybe just overwriting it?
So I'll get into that a little bit more in a second.
Okay.
We actually do want to detect Cobalt Strike's beacon. If any of you guys have used Cobalt Strike, it's the big daddy of Armitage. It is awesome. Beacon is a very stealthy payload that we really, really like, and we want to find a way to detect it, because why not? And this is actually a really big one, self-detection. As it stands right now, because we are scanning a specific signature in memory, antipwny always finds itself as a threat. Every time we scan, because the signature of memory is inside our program, and it's loaded into memory, we find our own signature. So we actually do need to find a way to, filter out our own program in a smart way.
So what happens if I inject Meterpreter into the actual antipwny?
Yes, so that is actually the issue here. Is if the attacker has the time to get into your system and migrate into antipwny, you will not be able to find it in antipwny, which is exactly why we need a good self-detection system. However, telling it to scan itself right now results in true 100% of the time, so that's not really a good way to do it. And we do want to make the log file a little bit easier to use right now. That kind of started as an afterthought, and then we realized it's probably kind of important to have logging. So we actually did use a lot of different tools to get to where we are with this. I assume most people are familiar with procmon, but very few people have actually heard of proc.dot. This is actually an interesting tool that was put together to help analyze procmon files. I'm going to show them a quick screenshot. Yeah. So, for those of you familiar with procmon, procmon is a very nifty process written by the sysinternals team that lets you see what every process in your system is doing. Unfortunately, for all intents and purposes, it's impossible to read because it scrolls like 1,000 events across your screen every millisecond. So somebody designed this fantastic thing called procdoc, which is meant to help you analyze your procdoc files. So you send a CSV file in there, and you pick yourself a process, and analyze the whole thing. Let's do Java, because this is from a Java exploit that we actually analyzed a while ago.
You noticed the little pop-ups down here? That's
Yeah,
because of the
it's
persistence.
because of persistence. It's just you should probably kill that process.
Just turn it.
Yeah, just kill it. So this is actually an interactive graph of everything that a compromised process has done. We can show, you can see what files it created, what files it touched, what registry keys it touched, what TCP connections it made. And this is really invaluable. It helped us signature a lot of different things. And this is why actually our research started on Java exploits, because we found this cool thing and we're like, what can we do with it? Because that's how comp sci students think, is not, I have this tool, cool, what can we do with it? So we actually use this a lot to generate our different signatures for Meterpreter. For example, files that are dropped in your temp folder. This is how we originally found it.
I'm trying to do the play thing, but it doesn't work.
Our resolution is a little messed up.
Anyway, you can't really see it, but down there at the bottom has functionality to press like play, and it'll step through step by step what the process is actually doing.
We're gonna hide this.
No! He hates us right now.
Curse you demo guys. Alright, well, clearly Windows is freaking out like a lot. So it's probably not happy we spawned like 1,000 Meterpreter shells on it. Yeah, go back to the slides. I'm not sure if any of you guys have heard of Cheat Engine. It does exactly what you think it does. It's a tool that was written to facilitate cheating on computer games. You can attach to any process. You can scan memory. You can actually look at the whole memory of the process, and that's actually what I ended up using to find Meterpreter signature. We use the infamous TCP view. That is a competition's best friend because it allows you to play whack-a-mole with attackers, where they get in and then you say kill connection, and you do that for the whole competition. It's really fun. And Process Explorer, obviously. Process Explorer lets you see a lot of in-depth information about different processes. You can get information about DLLs that are loaded and stuff like that. It's pretty cool. So we actually did host this whole project on GitHub. That's your link right there if you want to go look at it. If you want to make pull requests, if you want to commit to it, be my guest. This is an open source IDS. If you guys feel like working on it together, we can possibly make a really sweet open source IDS that anybody can use at any given time. And the original goal for this project was actually just to create something that competition people could use to have fun with the red team, because they have fun at our expense all the time. So why not, give them a little payback with something that kills all their stuff instantaneously? But it kind of went a little bit bigger than that in the end, and we would like to see this continue a little bit more. One last thing I want to talk about really quick, and this is more in the theoretical sense of things. We actually did talk to Raphael Mudge, the creator of Armitage, and one thing he told us about was every single payload in Metasploit uses reflective DLL injection to add DLLs to a running process. And he said, if you can find the way Metasploit does that, you can find every single payload ever. So, being as I cannot resist a challenge, I went and sort of did that. That is currently what we're working on at our very present stage, is we are trying to find a way to signature and completely detect the payload mechanism for Metasploit. And as you were saying earlier, override the threads and stuff like that, we've actually managed to find the DLL call inside the reflective loader, which calls the function inside Meterpreter. So we were thinking of fun little things like, I don't know, overriding that with our own function call and sending random garbage back to the attackers. Or, not random garbage, maybe specially crafted garbage. But you know, that's a work in progress, and it's going to take a little bit more time. We think it'll be really cool if we can actually get that working. Anybody have any questions or anything?
Comments, suggestions.
Comments, suggestions, pull requests, like right now? No? Okay then, I guess I'll show you guys.
Thank you.
So you're pulling a lot of data from memory and other processes. Are you doing that natively in .NET?
Yes, we're actually using pinbook. We're using the native Win32 APIs to do it. There are no native .NET libraries that allow you to do this, unfortunately. And I will tell you that the Windows 32 APIs are like arcane wizardry. They're impossible to work with and understand. And that is actually one of the biggest hangups we had, trying to debug their crazy, crazy documentation that makes no sense. Anything else?